In 1947, in the high desert of Muroc Army Airfield in California, Northrop rolled out something that looked like it had arrived from another century. The YB-49 flying wing had no fuselage, no tail, and 4 jet engines buried inside the wing itself. It promised longer range, lower drag, and a payload capacity that conventional bombers could only dream of. Test pilots called it the most aerodynamically pure aircraft ever built. The numbers were extraordinary. The handling was treacherous. In June 1948, one of those prototypes broke apart in flight, killing all 5 crew members. The program was cancelled. The flying wing concept was effectively buried for decades. For decades since then, commercial aviation has accepted a painful truth. The tube and wing layout became the immovable template. Every airliner since has been a variation on the same theme: a pressurized tube, swept wings, engines slung below, and a tail at the back. In late 2027, a California startup called JetZero expects to fly the first full-scale blended wing body demonstrator, built specifically as a commercial aircraft precursor. The aircraft, called the Z4, targets approximately 250 passengers, roughly 5,000 nautical miles of range, and a fuel burn reduction of up to 50% per passenger mile compared with conventional jets. Commercial service is targeted for the early 2030s. But here's what makes no sense. JetZero has roughly $1 billion in committed funding. It has never built an aircraft. It has no certified product. A single new Boeing or Airbus program typically consumes tens of billions before first delivery. JetZero's entire war chest wouldn't cover Boeing's annual research budget. Yet, United Airlines, Alaska Airlines, Delta, Northrop Grumman, RTX, and the United States Air Force are all now financially or strategically attached to this company. So, how can a startup with $1 billion threaten an industry? To understand why JetZero is betting its existence on a shape the industry abandoned 70 years ago, we need to understand why that shape was abandoned in the first place. The conventional airliner is a compromise. The fuselage is structurally efficient for pressurization because a cylinder distributes loads evenly. But aerodynamically, the tube is dead weight. It produces drag without producing lift. The wings do all the lifting work. This created a permanent trade-off. Aircraft that carried more passengers needed bigger tubes, which produced more drag, which demanded more fuel. Every gain in capacity came with an aerodynamic penalty. The industry adapted by optimizing the edges. Boeing and Airbus improved engines, refined wing designs, replaced aluminium with composites, and shaved drag wherever possible. Each program delivered incremental gains, typically low to mid-teen improvements in fuel efficiency over the aircraft they replaced. The trade-off seemed permanent. Geometry always wins. Boeing and Airbus had every reason to stay conservative. A clean sheet aircraft program costs tens of billions of dollars. A bad program can damage a manufacturer for decades. Boeing 787 was nearly a decade late. Airbus learned similar lessons from the A380. So, both manufacturers settled into evolutionary upgrades: the A320neo, the 737 MAX, safer bets than a radical new architecture. This left a gap, the middle of the market, the space the Boeing 757 and 767 once occupied has been only partially filled by the A321XLR. Boeing once explored a new mid-size airplane concept but abandoned it. Airlines have been frustrated for years. Into this gap walks JetZero, with an aircraft shape that neither Boeing nor Airbus dares to build. The Z4 is a blended wing body. The fuselage and wings merge into a single, wide lifting surface. Instead of a tube that produces drag, the entire aircraft contributes to lift. JetZero's specifications target approximately 250 passengers, roughly 5,000 nautical miles of range, and compatibility with conventional jet fuel and sustainable aviation fuel blends. The Z4 is sized to fit existing airport gates, taxiways, and jet bridges. The headline claim is a 50% reduction in fuel burn per passenger mile. That number is transformational if real. Most modern aircraft improvements are measured in single-digit percentages, a few percent from engines, a few percent from aerodynamics, a few percent from materials. JetZero is promising a step change, of the kind aviation has not seen since the jet age began. The aircraft is positioned for transcontinental US routes, transatlantic missions, US to Hawaii flying, and thinner long-haul routes that don't justify a widebody, larger than an A321XLR, smaller than a 787. Exactly the space airlines have been begging someone to fill. Fuel is one of the largest costs in an airline's operation. Emissions regulations are tightening globally. Sustainable aviation fuel remains expensive and supply constrained. Hydrogen and battery electric aircraft are still distant from mainstream service. JetZero's pitch is unusually pragmatic. The aircraft uses conventional jet fuel. It can use SAF blends. It does not require new airport infrastructure. It does not depend on unproven propulsion technology. The aircraft is radical. The business case is conservative. In April 2025, United Airlines Ventures invested in JetZero. The agreement includes a conditional path to purchase up to 100 Z4 aircraft, with options for another 100, contingent on JetZero achieving milestones. This is not a firm order, it is optionality. But airlines do not casually attach their names to aerospace startups. United clearly sees a potential value in a 250-seat efficient aircraft. Alaska Airlines invested earlier through Alaska Star Ventures, participating in the Series A funding round in 2023. A 250-seat efficient aircraft fits Alaska's growth profile better than a widebody ever would. Delta took a different approach. Through its Sustainable Skies Lab, Delta is providing operational and design input. How does the cabin board? How does the aircraft turn around at the gate? How does catering work? Where do bags go? How do passengers evacuate? These are the questions that kill radical aircraft when answered too late. In January 2026, JetZero closed a $175 million Series B financing round, with participants from United, RTX Ventures, Northrop Grumman, and B Capital. Total funding and commitments crossed $1 billion. But here's where the JetZero story diverges from every other futuristic aviation startup. In August 2023, the United States Air Force awarded JetZero a $235 million contract to develop a full-scale blended wing-body demonstrator. The target first flight is early 2027. Aviation startups typically die in the gap between concept and full-scale prototype. Building a real aircraft is brutally expensive. The Air Force contract bridges exactly that gap. The military use case may be even clearer than the commercial one. Tankers and transports care intensely about range, payload, fuel burn, and operating cost. A blended wing body that carries more fuel, flies further, and burns less of that fuel on itself is exactly what the Air Force needs. JetZero may reach commercial aviation through the back door, not by starting with passengers, but by proving itself to the Pentagon first. Even if airlines move slowly, the military demand could keep the program alive long enough for commercial certification to follow. But there is a problem buried inside JetZero's specifications that the company rarely discusses prominently. The blended wing body achieves its aerodynamic efficiency by cruising at extreme altitudes, typically above 41,000 feet. At those altitudes, the air is incredibly thin. Modern high-bypass turbofan engines lose significant thrust in that regime. They are optimized for lower cruise altitudes where most airlines operate. So, JetZero selected the Pratt & Whitney PW2040 for the demonstrator. The PW2040 is a 3-generation-old engine that debuted in the 1980s on the Boeing 757 and now powers the military C-17. This creates an uncomfortable paradox. The PW2040 burns roughly 25% more fuel than a modern engine like the GE9X. The demonstrator will not achieve the 50% fuel burn target. It cannot. The 50% claim relies on the BWB aerodynamic shape eventually being paired with a modern, high-altitude optimized engine that does not yet exist in commercial form. That engine is a major unresolved variable in JetZero's business plan. This matters because the 50% number is what makes the Z4 commercially interesting. If real-world performance comes in at 20 to 30% better than conventional aircraft, the value proposition remains significant, but no longer transformational. Airlines may hesitate to accept the risk of a new manufacturer for incremental gains they can get from Airbus or Boeing. JetZero does not necessarily need to hit 50% to matter, but it needs to be better enough to justify being different. Designing an aircraft is hard. Producing it at scale is much harder. In June 2025, JetZero announced plans for a $4.7 billion manufacturing facility at Piedmont Triad International Airport in Greensboro, North Carolina. The plan targets over 14,500 jobs by 2036. It is the largest job announcement in North Carolina history. Construction is scheduled to begin in the first half of 2026. The facility will use AI-enabled digital manufacturing, automation, 3D printing, and composite production techniques. At full capacity in the late 2030s, the plant aims to produce up to 20 Z4 aircraft per month. North Carolina secured the project with up to $1 billion in job development investment grant support and local performance-based incentives. Guilford Technology Community College has already expanded its aviation programs to feed the workforce pipeline. JetZero does not just need to invent a new aircraft, it needs to invent itself as an aircraft manufacturer. This is where most startups collapse. Mitsubishi spent 12 years on the SpaceJet before cancelling without delivering a single passenger aircraft. Boom Supersonic faces continual delays. Comac C919 took decades to reach limited commercial service. Production is unforgiving. Suppliers must commit. Quality control must be airtight. Cash flow must survive years of negative returns. Even Boeing and Airbus, with decades of experience, struggle to deliver aircraft on schedule today. Then there is certification, which may be JetZero's hardest technical hurdle. The FAA and EASA have spent decades certifying tube and wing aircraft. They have established methodologies, precedents, and test protocols. A blended wing body creates questions regulators do not normally face. Emergency evacuation from a very wide cabin presents new challenges. Passengers will be seated far from windows. Cabin pressure loads in a non-cylindrical body behave differently. Crashworthiness, fatigue, handling qualities, stall behavior, engine outperformance with engines mounted above and behind the fuselage. All of these require new certification frameworks. Evacuation is especially critical. Regulators require aircraft to be evacuated within 90 seconds, under simulated emergency conditions, using only half the available exits. A wide, short cabin with unusual exit geometry could make that benchmark harder to achieve. The Z4 will not be certified because it is clever, it will be certified only because it is boringly safe. Post-737 MAX certification scrutiny has intensified. The FAA is more cautious. International regulators are less willing to defer to American authorities. Every assumption must be tested. Every novel feature must be justified. The Z4 cabin will feel entirely alien to modern travelers. JetZero promises vertical interior walls, multiple aisles, 18-inch wide seats, and dedicated overhead bin space for every passenger. The engines mounted above and behind the cabin should reduce noise significantly. Boarding could happen through central doors, feeding multiple aisles, dramatically improving turnaround times. But the same wide cabin creates psychological challenges. Most passengers will sit far from any window. JetZero plans to use high-resolution digital displays inside walls and overhead skylights in the forward cabin to mitigate this. Whether passengers accept simulated windows the way they accept real ones is genuinely unknown. Motion dynamics also differ. Passengers seated far from the aircraft's center of gravity will experience different sensations during banking and turning than those near the center. Some seats may feel like amusement park rides during turbulence. The aircraft has to work emotionally, not just aerodynamically. If passengers see the Z4 as a luxurious, quiet, spacious leap into the future, it becomes a marketing triumph. If they see it as a windowless, motion sickness theater, it becomes a commercial liability. The blended wing body concept is not new. NASA, Boeing, McDonnell Douglas, universities and defense researchers have studied it for decades. Boeing and NASA flight tested the X-48 subscale demonstrator in the late 2000s. Northrop's flying wings predate jet aviation. The aerodynamic logic has never been the question. The question has always been whether a BWB could work as an airline product. JetZero is not trying to invent the concept, it is trying to commercialize it. That is a fundamentally different challenge, and arguably a more achievable one, because the underlying physics are already validated. The significance of JetZero isn't really about whether the Z4 enters service in 2030, and it isn't about whether JetZero becomes the next Boeing. It's about what an aerospace startup can do to an entire industry's assumptions about what an airliner has to look like. You see, JetZero doesn't need to replace Boeing and Airbus to matter. It just needs to prove that the blended wing body works as a commercial product. If the 2027 demonstrator flies and validates even most of the aerodynamic claims, the strategic landscape changes immediately. Boeing is weakened, the 737 MAX fallout, the 787 quality issues, the 777X delays, the balance sheet pressure, and intensified certification scrutiny have left Boeing unable to launch a clean sheet commercial program for years. That weakness creates space for outsiders. Airbus is stronger. The A321XLR gives airlines narrow-body economics on long routes. The A330neo and A350 cover the wide-body market. Airbus has less urgency to gamble on a radical new architecture. So, JetZero exists, in part because the duopoly cannot or will not take this kind of risk right now. JetZero's biggest success might not be replacing Boeing or Airbus, it might be forcing one of them to take the blended wing body seriously. Boeing and Airbus cannot pivot to a BWB architecture in a few years. Their entire production systems, supplier ecosystems, and certification expertise are built around tube and wing aircraft. A new architecture would require new tooling, new factories, new supplier relationships, and new certification work. It would take a decade, minimum. Meanwhile, airlines are already engaging with JetZero. The competitive clock is ticking, even if the airframe itself is years away from service. Yet every manufacturer must now account for what JetZero is demonstrating. The assumption that tube and wing is the only commercially viable aircraft is no longer absolute. The assumption that incremental improvements are enough is suddenly vulnerable to a step change. The race to evaluate alternative airframe concepts is accelerating precisely because the legacy players recognize the competitive implications. When that demonstrator lifts off in 2027, it will complete a journey that took 80 years to make possible. $1 billion, a handful of airline partners, a Pentagon contract, and proof that sometimes the most significant changes in aviation don't require hundreds of billions of dollars. Sometimes they require conviction, a validated shape, and the willingness to bet that the next great airliner won't be a tube with wings, it will be the wing itself. The question isn't whether one startup can change the shape of aviation, it's whether the rest of the industry is really paying attention. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?